Hi, welcome to class. My name is Don Lafond, Professor Don, and this week in Cisco 1, we are covering Module 13, Internet Control Message Protocol, ICMP. This presentation is relatively short, should be here just for about 30 minutes or so. I know you guys like to hear that. I'm going to go ahead and share my screen and start the presentation. If you have any questions, please ask your questions after the presentation if you're here with me live, or if you're watching this presentation as a recording inside of NetAcad, please ask your questions inside of our NetAcad help forums. If you're watching it out on YouTube, then please ask your questions in the comment section below the presentation, and I'll be happy to answer those questions. But of course, it's awesome if you help each other out, especially out in YouTube. All right, so again, this is Module 13, Internet Control Message Protocol, ICMP. We are going to learn about ICMP. We're going to use various tools to test network connectivity, including an introduction to the actual ICMP messages and how they work. And then we will use ping and traceroute to use ICMP to test network connectivity. ICMP messages. Hang on just a second. This, and if for some reason if I lose volume, please let me know, students, so that I've been having a problem with my mic just dropping out, so please let me know. All right, so Internet Control Message Protocol, ICMP, provides feedback about issues related to the processing of IP packets under certain conditions. ICMP is the messaging protocol for IPv4, and ICMP-v6 is the messaging protocol for IPv6 and includes additional functionality. The ICMP messages common to both ICMP-v4 and ICMP-v6 include host reachability, destination or service unreachability, and time exceeded. Now, ICMP v4 messages are not required, and often administrators disallow those messages within a network for security reasons. We'll find out later that an asterisk does not necessarily mean your connection wasn't made. It might just mean that the network administrator did not allow the IPv4 address to be sent back. All right. So ICMP echo messages can be used to test the reachability of hosts on an IP network. In this example, the host sends this initial packet to the destination. And if the host is available, the destination responds with an echo reply, basically indicating that all of the equipment between the host and the destination IP address are correct. Okay, that proves that whole line out. We'll come back and look a little closer at that a little later. So you have an ICMP echo, that is what's sent, and then an echo reply is what is received in return. Now, the destination or service unreachability. Now, an ICMP destination unreachability message can be used to notify the source that a destination or service is unreachable. Pretty much why we use these tools. The ICMP message will include a code indicating why the packet could not be delivered. Now, the commands for IPv4 and IPv6 are listed here, and you notice IPv6 has a few additional ones. So ICMP v4 net unreachable is the same as no route to destination, pretty much the same command. Host unreachable is pretty much the same as address unreachable, and then port unreachable is the same as port unreachable, obviously. Now, there's a couple extra ones here indicating communication with the destination is administratively prohibited. That's IPv6 only, and beyond the scope of the source address. That indicates that I believe it's outside of the network. But you have to memorize each set of ICMP messages. Again, this would be useful to put in your tech notebook, but these error messages will not be available unless you memorize them for the exam when you go to take your CCNA certification. Now, when the time to live field in a packet is decremented to 0, an ICMP v4 time exceeded message will be sent to the source host. The ICMP v6 also sends a time exceeded message. Instead of a TTL field, the ICMP v6 uses the IPv6 hop limit field. Pretty much the same. They're a little bit different, but they are pretty much the same. They suit the same purpose. Now, notice in this this ping, they pinged 8.8.8.8, and they got a reply. But notice the time to live expired in transit, indicating that you have a problem. Now, ICMP messages have new features and improved functionality that are not found in ICMP v4, including 4 new protocols as part of the Neighbor Discovery ND or Neighbor Discovery Protocol NDP. Now, messages between IPv4 router and an IPv6 device include dynamic addresses and are allocated as follows. The router solicitation message is sent to ask the router for information, and an advertisement is sent automatically every 200 seconds. We learned that earlier in the semester. That's a router advertisement message. Now, messaging between IPv6 devices, including duplicate address detection, DAD, and address resolution, include neighbor solicitation messages and neighbor advertisement messages. Now, we haven't talked about that yet, but it's basically how neighbors, IPv6 enabled devices, talk to each other within the network. Now, ICMP v6 neighbor discovery also includes the redirect message, which has a similar function to the redirect message used within ICMP v4. Now, router advertisement messages are sent by IPv6 enabled routes every 200 seconds to provide addressing information to IPv6 enabled hosts. Router advertisement, and I'll cover that a little bit more in depth on the next slide. Router advertisement messages can include the addressing information for the host, such as the prefix length, DNS address, and domain address. A host using stateless, where IPv6 addresses are not retained, stateless addressing auto configuration. That is what SLAC stands for, stateless address auto configuration, will create its own IPv6 address, and it will use the default gateway to the link local address of the router that sent the RA. It realizes that that is its default gateway. Now here you notice that a router advertisement is sent every 200 seconds. Basically, the router just pinging information in case there's a piece of equipment that needs it out on the internet, out on the network. Now, if an IPv6 enabled router, if the PC asks for an address, the PC, the host, a new host comes on the network, it doesn't want to wait 200 seconds, it can send out a router solicitation message asking the router for that information. The router will reply to that router solicitation with the router advertisement, and that's what this all says right here. Hey, I just booted up. Is there an IPv6 router out there as a broadcast? And then the router, any IPv6 router out on the network will respond and say, hey, you need to create your own IPv6 address. Here's all the information you need. And then it sends that back to the PC1. PC1 creates its own address, and then it sends it uses duplicate address detection, DAD, to make sure that that address is correct. By the way, use my local link address, FE80::1, that address right, I'm sorry, this address right here, that is where that FE80 is. Use that as your gateway default. Now, a device assigned a global IPv6 address, unicast, or a linked local unicast address may perform duplicate address detection, DAD, to ensure that the IPv6 address is unique. To check the uniqueness of the address, the device will send a neighbor solicitation. A neighbor solicitation message will be sent to its own address. Note, this is the IPv6 address for the PC. It's sending it to its own address. Why would it do that? Well, if there's a response to that neighbor solicitation message saying, yeah, hey, get off my address, I use that one, then remember we talked about addressing earlier. There's 18 quintillion addresses, so it is 1 in 18 quintillion addresses that is possible for you to get a duplicate address, but it is possible. So that's why you do the duplicate address detection, DAD. Now, DAD is not required because it's 1 in 18 quintillion, which is way more than winning the lottery. It's still possible, and RFC 4861 recommends that duplicate address detection is performed on all unicast addresses. Okay. Keep moving. To determine the MAC address for a destination, the device will send a neighbor solicitation message to the solicited node address. The message will include the known targeted IPv6 address. The device that has the targeted IPv6 address will respond with a neighbor advertisement message containing its Ethernet MAC address. In the figure, R1 sends a neighbor solicitation message to, I believe R1 is sending it to PC1, and then PC1 responds with its MAC address back to R1. Now, this is why IPv6 doesn't use ARP like IPv4 does, and this is a little bit better than ARP because it doesn't have to go all the way to doesn't have to go up the OSI model to get the MAC address. All right, now that's everything we're going to learn about ICMP. Now we're going to use ICMP protocol to see and use ping and traceroute to test our network. Now, the ping command is an IPv4 and IPv6 testing utility that uses ICMP echo requests and echo reply messages, what we were just talking about a few minutes ago. These messages are used to test connectivity between hosts and provides a summary that includes the success rate and the average roundup time to the destination. I am certain that you guys have all used ping in this class to make sure that your networks have been properly configured. You may not have known that you were using ICMP to do that, though, but you just ping. In this case, they're pinging 192.168.20.1, 20.2, and they got 80%. Now, the reason why they got 80% in an IPv4 address on a host is because that first ping timed out because ARP or neighbor discovery needed to be performed. If you were to run that ping a second time, then the MAC address table, a CAM table, would have the information and it would succeed 5 times. Now, ping can be used to test a host's own internal configuration for IPv4 or IPv6. To do this, ping the local loopback address of 172.0.0.1 for IPv4 and : 1 for IPv6. It's actually a whole range of addresses. You could ping 002, 003, or : 2, : 3, and it would work. Those loopback addresses are used, the whole range of the addresses are used so that you can have simulated networks out there. So you can have a network 127.0.0.1, 127.0.0.2 in a simulated environment for training. But anyway, so you can ping any of those addresses. If you get a response, that means that your IP circuit is correct. Your protocol, your IP protocol is properly installed and configured correctly. If you get an error message, that means you have a problem with your TCP/IP stack, and you need to look internally to see what that problem is. Now, yep. And the ping command can be used to test the ability of a host to communicate on the local network. So if you ping your local link and your loopback address and it works, well, then now you know you're okay. Now you ping your default gateway, for example. If you ping your default gateway and you reach your default gateway, you get an echo reply and it says that you reach 4 out of 5 times and then 5 out of 5 times. That means that you and your network is configured properly. Now, if there's another host over here, maybe you ping them to find out if they're having a problem, or they ping you to find out where the problem is. But if you can ping the default gateway, then and you can't get out to the internet to another network, then the problem is with the router or something beyond the router. Now, to test that, you want to ping something outside of your network. So in this case, we're going to ping 10.0.0.1 over here. If we get a reply, now we have proved that you are able to get out to the internet. If you can't ping 10.0.0.2, the problem is here. If you can't ping some other network out here, the 10.0.2 network that's out here someplace, then the problem is out here someplace. You're fine. If you can ping any other network device on a different network, then you can reach the internet. You've just proven that your router is properly configured. All right, so that proves, using ping, it just proves that you have connectivity. Now, the next tool that we're going to learn is Traceroute. Now, Traceroute is for routers, okay? If you're on a router, you use Traceroute. Tracert is if you're on a Windows computer, or other computers as well, but I use Windows. So Tracert. Now, how you remember which tool to call it and what the command is, see, if you're on a router, it's Traceroute, is just remember route is on a router. If you see Tracert, that's not a router, so it's got to be a host, a PC. Remember, a router is just a fancy PC, a special purpose PC. It works the same way. The command works the same way. It's just a different command. So anyways, Traceroute for routers, Tracert not for routers, all right? Now, Traceroute is a utility that is used to test the path between hosts and provide a list of the hops that were successfully reached along that path. Traceroute provides round-trip time for each hop along the path and indicates if the hop fails to respond. An asterisk is used to indicate a lost or unreplied packet. Now, an asterisk doesn't necessarily mean that you have a bad connection. It just means that that device either is broken and a problem, or that device has ICMP turned off. If ICMP is turned off, then the packet will still get to the device, but the administrator, the network, is not allowing ICMP packets, the echo replies, to be sent back to the echo request. It's not an echo request. I'm forgetting right now. But anyways, so basically, you reach out. If it goes past the asterisk, you know it made a successful hop. It just didn't respond. It just didn't give you the IP address of that intermediate stop. And it might be because that route is inside of somebody's network. It is an unusual you can ping different IP addresses, maybe the school's address or something, and you'll see some hidden routers. They still work, they still respond, they just don't give the IP address when they respond. Now, this information can be used to locate a problematic router. If it doesn't get past the asterisk, that means you have a problem in the path, or it may indicate that the router is configured not to reply. Traceroute makes use of a function of the TTL field in IPv4 and the hop limit field in IPv6 in the layer 3 headers, along with the ICMP time exceeded messages. This is just what it looks like when you get the reply, indicating that you from your host from your IP address, you are pinging another address. Actually, why would you ping your own address here? Hang on a second. All right, so here we are pinging our own address, traceroute to the route. Why are we? I'm sorry. We are doing a traceroute to this address. That's not our address. And then it gives you tracing, and then it gives you all the hops along the way to get to that address. Notice the last address is 10.1, I'm sorry, 192.168.40.2. That's the last address. It had to hop between these IP addresses to get to that address. All right. So now they show that and how it works in using the TTL field. The first time it sends the trace route, it sends a TTL field of 1. It goes out to the first router. First router responds, saying that the ICMP timed exceeded message. It sends that message back. Then it sets the timeout to 2. The next router does the same thing. It says exceeded, it sends it back. It knows it got to that router. Then it sends it again with 3. It gets to this router with the third TTL, and then that gets sent back saying exceeded. And then it sends the fourth and final one to the actual destination. And then once it gets to that destination, now you know you've made it to the device, and that proves that you were able to make it out of your network and then outside of your router, your default gateway router, and then out on the network, it shows you all the routers in between, and that could change every time you do a trace route because the path can be different. And then ultimately you get to the destination. Now you know you are good to go to reach 192.168.1.2 in that final IP address. Okay, now you are going to do a packet tracer where you're going to verify IPv4 and IPv6 addresses. You're going to use packet tracer to use ping and traceroute to test a network connectivity. And you're going to use a packet tracer to test and correct network connectivity. So there will be a problem in this assignment that you have to fix. And then finally, you're going to do a lab to use ping and traceroute on real equipment. Here at the school, we use NetLab. If you are using equipment at your home, then use the lab assignments. Remember, you can get all of these assignments, all of the labs you can find out on itexamanswers.net. Just search for the packet tracers and the lab with Cisco One, and you will find them. It's itexamanswers.net. They don't pay me. Maybe they should, but they don't. And this website is awesome to help you to reinforce what you're learning here in NetAcad. And if you don't have NetAcad, it's one of the best sites out there to get information. Now, don't use the IT answers to answer the test questions for our class, please, because you're not learning anything when you do that. All right, so that is our presentation. As I said, the presentation was going to be short and sweet, especially compared to the last couple on IPv4 addressing and IPv6 addressing. This was so much easier, and you're going to find the assignments to be easier as well. If you have any questions and you're here with me live, hang on, I'm going to give you an opportunity to ask those questions. If you are watching this presentation as a recording inside of NetAcad, please ask your questions inside of NetAcad and the help discussion forums, and I will be happy to help you. And so will your fellow students. And if you're watching it inside of YouTube, please ask questions down below. Also, please rate and respond. That helps me out. Rate and subscribe. That helps me out as well. And you'll get updates when I post future videos. And I really appreciate that. So that's it for today's presentation. Again, my name is Don Lafond, Professor Don. It's been my pleasure teaching you Module 13, and I look forward to seeing you next week. Have a great week.